Here. Yeah, thank you, everyone. My name is Gloria, and I will be talking about my project titled Surprising Sounds Influence Risky Decision Making. So this project was conducted fully online and consists of 4 main experiments, which I ran over the course of about a year. And I'm excited to share with you its results and also what it has taught me about online research. So to start, imagine that you're in a busy city. In this urban jungle, there are surprising sensory events everywhere. You can imagine the sound of a car honking for you to get out of the way, or the sound of an approaching subway car approaching you. So in response to these surprising sounds, you might quickly change your behavior. This could mean changing course on the pedestrian crossway or quickly jerking backwards away from the platform edge. In both of these instances, an immediate behavioral response to a surprising sound can be surely adaptive because it can protect you from an immediate danger or alert you about a potential reward. However, but after being in these environments for a while, you might notice that most of the time, the abundant noises that you're surrounded by are actually behaviorally irrelevant. Think about a time when you were stuffed inside of a crowded subway car on your morning commute, and while you're trying to focus on doing your crossword puzzle, or as you're writing up a message to a friend, you hear someone's ringtone going off on the side or the sound of a conversation happening in the background. These are also considered surprising sensory events, but it's a little bit less intuitive what kind of immediate effects it might have on your behavior, if at all. And if so, whether those effects on your behavior are systematic or not. So this is the kind of thing that we were wondering about whether, task irrelevant or behaviorally relevant surprising sounds really affect our behavior. And we decided to look at this general question in a smaller domain of risky decision making. And so now the question kind of becomes, do surprising sounds systematically affect our risky decision making, even when those surprising sounds are actually task irrelevant? So this is the way that we took a stab at this question. And we asked participants to make choices between a risky gamble option, so like a unbiased coin flip essentially, or a safe option in every trial. And with a keyboard press, they can decide to choose the risky option. And after a short delay, they get to see whether they've won or lost that. Or they can choose the safe choice by clicking another keyboard key. On every trial, participants can see one of 3 different types of trials. So they can either see a gain trial, which is at the top, which features either a potential gain or a smaller potential gain, or a loss trial, which involves only potential losses, or finally a mixed trial, which contains a mixture of potential gains or potential losses. So this is a pretty standard paradigm used to measure and kind of capture people's risk-taking preferences. The key, though, is that we introduced surprising auditory sequences, or we introduced auditory sequences to this paradigm. So in the inter-trial interval, so in the 3 seconds before participants are shown their next set of options to make the choice, participants have to passively listen to a 6-tone auditory sequence. And what's important to note is that these auditory sequences are supposed to be task irrelevant in the sense that whatever sounds that they hear are completely not predictive of whatever they're going to be shown next, and it's not going to be predictive of the rewards that they're going to get. So on a majority of trials, so on 75% of trials, participants will hear what I'll consider a common sequence. So that's on the bottom row here. And this common sequence, as shown in the graphic, consists of 6 identical tones. So I'm going to try to play that for everyone, and I hope it's not too loud. Let me see. Okay, yeah, so I've just played this. This is the common sequence, consists of 6 identical tones. Now, on 25% of trials, so on a minority of trials, people will actually hear a rare sequence. So this rare sequence will start off the same way as the common sequences do, with 5 tones, but at the end, it will have a different ending. So in this graphic here, it shows that it ends on a tone that has a different pitch. And so this rare sequence will sound like this. Okay, so now you can kind of imagine that sometimes on a rare trial, participants would be like surprised, and we kind of wanted to capture or to analyze how does risky decision-making differ on these rare trials as opposed to common trials. Okay, so this is how we approached the way that we collected our data. So there were several factors that drew us into conducting all of our experiments online because of the many advantages of doing online research, which includes having access to large pools of participants. And we also have, the ability to collect large and also diverse samples. Like for example, in Prolific, there's the option to gender balance our samples, which is a very nice feature. And also probably the biggest advantage is that it's extremely time efficient to conduct studies online. Typically in the lab, if you wanted to collect a data set of 100 participants, it could take months and it can be incredibly expensive in time and money to run. But the fact that we can press a button and essentially collect their whole data set in a day is a huge plus. However, all of this flexibility and convenience does come at the expense of having maximal amounts of experimental control over our participants' environment. In our case, the crux of our study was really to see how a specific sound manipulation can influence people's behavior. And so it's extremely important for us to make sure that the sound manipulation is really doing its job so that we know that our results can be trusted and are valid. So thus we came up with 4 different considerations, which have to do with kind of addressing some of the common disadvantages of online research. The first one is getting at the question, is the sound even on? So this sounds trivial almost, but however, when people are doing experiments at home, they're using different browsers, they might have ad blockers on. So there's no guarantee that, due to technical issues or something, they, for some reason, can't hear the sounds. Another one is, does the audio have sufficient sound quality and clarity? So this is a big one because we can't control the types of auditory equipment people use. And so the variability there is immense and we want to find a way to constrain that. Third one is, are there distractions or background noise? Yeah, so participants could be doing this outside, they could be doing this in public or at home. And especially given that our study is all about studying how irrelevant, surprising sounds affect people's behavior, we definitely want those irrelevant, surprising sounds not to come from their own environments, but from our task specifically. And finally, we wanted to make sure that participants are following basic instructions. So this is not specific to our study, of course. In general, we want participants to be attentive, to be compliant to instructions, and generally doing our task in good faith. So now I'll show you how we structured our experiment. So we had used Gorilla as the hosting and experiment building platform for our experiments. And so you can see here, it's like I drew out a graphic summarizing the experiment tree that participants kind of progress through. So in the first 5 minutes of the task, we have participants complete 2 screeners. Both of these were sourced from Gorilla's open materials library, which is nice. And so the first one is the browser autoplay sound check. So this one's super basic. All it does is that it plays 2 seconds of like a music clip and it asks people whether or not they can hear the music, yes or no. If they can't, then it leads people through some instructions on how they can maybe disable an ad blocker or something to fix the problem. And otherwise, if they can't, then participants are given the option to exit the study early and return their submission. We thought this would be adequate for addressing consideration 1, which is whether the sound is on or not. Then people would progress into doing the headphone screen. So this is based off of the loudness judgment task developed by Woods and colleagues. And essentially all it does is that it has participants listen to a sequence of like 3 auditory tones, and then participants then have to label which one sounds the quietest. And what's important to note is that this screener is really easy to pass if you're wearing headphones, but it's difficult to discriminate between the 3 tones if you are playing sound from your computer but not wearing headphones. So essentially those who achieved more than 5 out of 6 in accuracy for this screener would pass the screen. So overall, these screeners in the beginning resulted in around a 30% exclusion rate in our experiments. And so we collected enough data so that by the end, we were able to analyze 200 participants in our main risk-taking task. Okay, and very quickly, I'll now talk about some of the specifications we use for Prolific. So we use Prolific as our main platform for recruiting our participants. For the device requirements, we just made explicit that desktop is required and also that there's audio in the experiment. And in the study description, we tried our best to be as upfront and clear as possible. This is not what we wrote for participants verbatim, but essentially we wanted to get 2 messages across. We wanted to make sure people's ad blocker was turned off and also that headphones are a required part of doing this experiment. So we wanted to put that upfront before people even accepted the study and did the screeners. And lastly, for the pre-screening that we did on Prolific, we kept it quite loose actually. We excluded participants from previous studies. So we had used Prolific to recruit participants to do pilot versions of earlier iterations of our experiment. So of course, we didn't want to invite those same participants to come back into our main study. All right, so now that I've gone over the nuts and bolts of how we ran this experiment, I'll talk about the results that we found. So in front of you, at the top, you see the 2 experiment like paradigm descriptions. It's of experiments 1 and experiments 2, each that we collected 200 participants on. They're virtually identical in terms of the kind of structure, where there's 75% of trials are common, 25% of trials are rare with like a deviant ending. But the only difference is that for experiment 2, we periodically switch the sides of the stimuli left and right every 10 trials or so. But otherwise, our predictions for the 2 experiments would be very similar. So what we found was that surprising sounds increase people's risk-taking. So the plot you see on the left here, what I've done was that I took the difference of the risk-taking rate of rare trials minus common trials. So since these bars are significantly positive, that suggests that people are taking more risks for rare trials relative to common trials. And what's nice is that experiments 1 and experiments 2 are both in agreement with each other on this result. But from these plots alone, we can't tell whether this increase in risk-taking is driven by only like a subset of trials, for example. So one question I had was, is this driven by gain trials only, for example? So what I did was that I combined these 2 data sets, so I had enough data, and I broke out all the trials into gain trials, mixed trials, and lost trial types. And then I plotted that against the rate at which people chose the risky option. So what you can see here is that based on this kind of stair-step looking pattern, irrespective of the trial type, so in all 3 trial types, participants showed increased risk-taking for rare versus common trials. So what this is suggesting now is that not only are people taking more risks just in general, we can see that it's happening in all different types of trial types, irrespective of whether there's potential wins or potential losses at stake. So with this kind of systematic effect of risk-taking, we went to capture this in terms of a computational model. So one of the advantages of using this really basic risk-taking paradigm was that it's very well characterized computationally. So there's a foundational theory called prospect theory, which captures people's risk-taking preferences as a function of people's loss aversion. There's a parameter for that. There's parameters for risk aversion for gains and losses. And finally, there's a choice stochasticity parameter. On top of this, on top of prospect theory, we went ahead and added an additional risky bias difference parameter, essentially to capture a value-independent bias that would capture the difference between risk-taking for rare trials versus common trials. So this risky bias difference parameter, a positive one would indicate increased risk-taking for rare trials, whereas a negative risky bias parameter captures a bias towards the safe option. So on the left is the plot that you've already seen, and on the right, I took the model-derived risky bias difference parameter fit for the 2 experiments. And what we can see is that it's significantly positive in both experiments, matching what we see in the model and free model independent analyses. So this is quite reassuring, actually, that we found this. Okay, so on the left, you see the experiment designs for experiment 1 and 2. And what we found now is that following rare sequences, participants are increasing their risk-taking. However, from these 2 experiments, the way that it's designed, we're not sure if people are taking more risks because people are kind of recognizing that they've heard a rare sequence because it happens 25% of the time, or if it's because people are simply reacting to the deviant tone at the end of the rare sequence. So what I did was that I devised 2 other experiments for experiments 3 and experiment 4, such that now the rare sequence no longer ends in a rare or novel ending. Instead, it ends on the common tone. So the question now becomes, after rare sequences, do people still increase their risk-taking? And what you can probably guess from the title, it actually completely eliminates the effect. So now I'm showing that when we, in a sense, I remove the local surprise from the rare sequence, I actually get rid of the risk-taking effect, which is a really cool and striking result. All right, so let me summarize what I found. Incidental surprising sounds really do systematically increase risk-taking, and I show that in experiments 1 and 2. And I show that this effect is consistent for both behavioral and computational modeling-based analyses. Next, I see that the risk-taking effect of surprise can be eliminated simply by slightly, tweaking the statistics of the auditory surprise. And as I showed with the methods and how I built the experiment, I showed that headphone screeners were used to enhance data quality and helped address the challenges, and you can call them disadvantages, of online research. So that's the thing about like these disadvantages of online research, right? Such as, for example, having poor control over experiment setting or having lack of experimenter supervision. At the end of the day, these could all turn out to be a huge advantage at the end, which is something I found once you've established your results. So essentially, the participants from my study were recruited from over 12 different countries. We're in the presence of potential distractions, and we're probably doing the experiment during different times of the day. And yet, despite all of that, we're still able to characterize clear systematic effects of surprising sounds on people's risky decision-making that were robust to all these varying conditions. So doing this experiment online instead of in the lab definitely made things harder for us in some ways because we had workarounds that we needed to do, but it ultimately made the results feel a lot stronger and more generalizable. So I think this gives me a lot of optimism about doing online research in the future, and it can be daunting, but also really rewarding in the discoveries it allows us to make. Thank you very much. That's the end.
Gloria, that's amazing. I love that last point you were making, how we love the control of the lab. It feels safe and controlled. I'm sorry, the control of the lab, but it makes our results less robust and less reliable. And of course, taking the research online makes it harder to get it right and to get that data and to design your experiment so that it works and that you believe the data. But when it does work, you feel much more confident that the result is robust and is going to persist into different environments. So that was a really lovely point at the end. I did have one question for you. Once participants have passed the headphone screener at the beginning, how do you make sure that participants continue to play the task with sound throughout the whole experiment? Is that something you looked at?
Yeah, that's a really good question, Joe. So one thing that I didn't discuss in this experiment was I only focused on the pre-screeners that happened before the experiment. So we actually had some questions, like some checks during the actual main experiment, the main task. So what we've done was that we call this expectation checks, where participants have to listen to, they have to play both tone sequences, and then they have to label which one they thought was common or not. So this was kind of a test of like whether they've, listened to instructions on keeping their headphones in throughout the task, or also have they comprehended the task enough to kind of distinguish between what is rare and common. So we asked this both at the beginning of the experiment and also at the end of the experiment. And while we did realize that, some bad actors could potentially not be wearing headphones throughout the whole experiment. And then when they see a question like this pop up, they, put the headphones back in and then listen to it and answer it correctly. So in that way, the check is still corruptible, but we think that but probably can't be very common, I suppose. So we did have this, and thankfully, after looking at my data to see people's accuracy on these expectation questions, average accuracy on it was like above 95%. So that was quite reassuring overall. So it sounded like after the screener, people did seem to be quite good at the task and also able to discriminate between the different sequences.
Yeah, and so it sounds like we don't get many bad actors on Prolific, which is what they promised us. I don't know if you were here from the talk from Prolific this morning. They do quite a lot of checks to make sure we get good quality participants from them. So that's all very reassuring. There is one question in the Q&A, which is from Laura. This result seems opposite to what one would expect. How do you interpret the increased risk-taking after surprising sound if they might process this as a threat cue rather than your tones, which are fairly neutral, I guess?
Yeah, exactly. Thanks. That's a great question. And that's something that we have been thinking about a lot, which is like, what is the valence of these surprising sounds that are occurring? So I guess we tried our best to keep that as neutral as possible, and that we weren't using stimuli that are known to be aversive, such as like screams or things like that. It is very interesting that it increases our risk-taking. I think the way that we were kind of understanding this effect was that there is kind of like an orienting response that participants might be getting when they are hearing the surprising tone, which we thought was consistent with approach behavior, in the sense of you can think of a naturalistic example, like a frog, and suddenly there's a stimulus that comes up like a fly, and it immediately decides to approach that stimulus. So based on the behavioral results that we found, that this was kind of like a value independent approach motion, we thought this was consistent with this bias towards risky decision making. Yeah.
Brilliant. Thank you, Gloria. Thank you so much for your time, Gloria.